Let me start the recording. So with the square root there, I'm going to focus in on the square root. And when I focus in on the square root, I can factor out within the square root x squared, which means I'm dividing each term by x squared. So that's why I get 1 here and then plus 4 over x as my second term. Once I've factored out an x squared off of those two terms, then I can take the square root of each one individually. So the square root of x squared is just x, and that leaves me 1 plus 4 over x. So this is just a reminder of what we were doing last year and also what we were doing yesterday. So we have x, and then this is going to be minus x, the square root of 1 plus 4 over x. So I'm actually going to do the one with the cube root this way, because the one with the cube root on your homework is much easier to do it this way than try to multiply by the cube root. It'd actually be 2 over 3. The power would be 2 over 3 to make sure that it comes out of the cube root. So once I've done that, is I'm going to factor out an x. So the limit, oh, it's just y. Oh, that should be x. As x goes to 0. So let's make this as x goes to 0, or x goes to infinity. Make that x. Okay, so now I'm going to factor out an x, leaving me 1 minus, and then I have the square root of 1 plus 4 over x. 4 over x. X. Okay, now right now what I have is I have an infinity multiplied by infinity, but what I want is I want this to be, actually it's not even multiplied by infinity, it's multiplied by 0. So multiplied by 0. But what I want is 0 over 0 and infinity over infinity. So I'm going to use that rule again, that if I have 1 over b, this is going to equal to b. So reversing that, I'm going to rewrite this as the limit as x goes to infinity of 1 minus the square root of 1 plus 4 over x divided by 1 over x. Now what I have is I'm going to have 0 over 0. So if I put as x goes to infinity, the numerator is going to end up being, that's not what I want to do. The numerator is going to end up being 1 minus 1, which is 0. And then in the denominator, this is also going to be 0. So now I have 0 over 0, which says I get to use the L'Hopital's rule. Now, I don't know about you all, but I'm not a fond fan of the chain rule when I have square roots and I have x's and denominators within the chain rule. So I'm going to do something called U substitution. Do you all remember U substitution and all the glory that we had? So I'm going to go over here and say I want to make my life easier. I'm going to let U equal 1 over x. So that's going to allow me to replace 1 over x wherever I see u. But because with u substitution and I have the limit as x approaches, then I have to do a replacement right here too. Because when we're doing limits, it's kind of like doing, basically it's setting us up to be able to do derivatives, and which means that we're going to use this stuff for integrations. So I have to change that. So as x goes to infinity, this thing right here, this 1 over x, u will go to 0. So as x gets really large, the way I defined u will go to 0. That means this is going to be equal to the limit as u goes to 0, because I'm changing it to u. And then I have 1 minus the square root of 1 plus. I'm going to rewrite this 4 over x as 4 multiplied by 1 over x. And the reason I'm doing that is so that I can write that as u. So I have 4u. And then in the denominator, this is going to be u. This is going to make my life easy now, because what I have still is 0 over 0, which is cool, which means I can now do L'Hopital's a lot easier. So I still have to do L'Hopital's, but it's going to be much easier to substitute 0 in when we do L'Hopital's. So using L'Hopital's, it says I can use the derivative of the numerator separately than the denominator. So the limit as u goes to 0, when I do the derivative of the numerator, the derivative of 1 is 0, and then I'm going to have minus, because I'm going to do the derivative of the square root. I'm going to rewrite the square root as 1 plus 4u raised to the 1/2. That's going to make it easier for me to do the derivative, because that's going to be a minus 1/2, and then 1 plus 4u raised to now the negative 1/2. And then I have to do the derivative of the inside. The derivative of the inside of the square root is just going to be 4. And then in the denominator, the square root of u is just 1. So now I get to use direct substitution. When I put in with a direct substitution 0, I'm going to get negative 1/2. I'm going to get 1 plus 0 raised to the negative 1/2 and then multiplied by 4. So my final answer is just going to be negative 1/2 times 4, and so in other words my answer is negative 2. And because of the u substitution that I started up from up above, I don't have to go back and resubstitute unless I really wanted to, and I'm not a fan of resubstitution. Once I've done the substitution, I typically don't go back and redo the substitution. What kind of questions do you have for me on this one before I do the cube root one, which is similar to your homework? What kind of questions do you have for me? You can unmute yourself and just ask the question, or you can type in the question in the chat. Whatever is the easiest for you. Just going to put the question is, where did the 1 go? Well, on this one, what it really is 1 over the square root of 1 plus 0. So it's just 1 over the square root of 1, which is just 1. And so that's how come I didn't worry about the 1 in the next line right here. What other kind of questions do you have for me? Let's take a look at one that's similar to the homework that you're going to see. It's like the second question in L'Hopital's. Yes, so the question is, for Amber asked, is can I just do that, when I do that substitution, is that going to change the limits? Yeah, so option A is, when I do the substitution, I have to change the limit. Option B is I don't change the limit, but then I have to reback substitute. I'm not a fan of reback substituting, so if I'm doing the substitution, I do have to change the limit part, this part right here. So I do have to change that part. So if I do u substitution here, then I have to change the part of the limit as x goes to. It will now be as u goes to, because I've changed the value of, or I've changed my argument to u instead of x. So I've changed the variable. Any other questions before I set you all up to try the one that's like the homework? Okay, so I'm going to come over here and I'm going to write it and I'm going to start it, and you all are going to finish it. So the limit as x goes to infinity of, let's do x minus x cubed minus 4x squared raised to the 1/3. So this is going to be similar to what you're going to see on the homework. Now, I could do this by doing like I did yesterday with B, is multiplying by, and I'm not going to for this. I'm going to do the u substitution. If I were to do it similar to what I did with it yesterday, is I would now have to multiply by x cubed minus 4x squared raised to the 2/3. And it has to be raised to the 2/3 so that I end up with an index that is 3/3. Now, what's going to happen is this is going to get really ugly algebraically. So if I can avoid the ugly algebraically, I will. So rather than doing it that way, which you can, I'm going to do it by the u substitution. So I'm going to do the same steps as I started out with. So write this as the limit as x goes to infinity, x and then minus, as I did before, this is the cube root of, I'm going to factor out an x cubed out of the two terms, so I have x cubed 1 minus 4 over x. And then that allows me to do this, x, the cube root of 1 minus 4 over x. So just like I did before, I'm allowed to factor out that cubed, which means the x cubed becomes a 1, because I'm dividing each one of the terms inside of the cube root by x cubed. And that way I can take the cube root of x cubed by itself, and then whatever's left over. So following the same pattern, the limit as x approaches infinity of x, I'm going to factor out 1 minus the cube root of 1 over 4x. And again, what I have is infinity times 0, which is really hard to determine. So I'm going to use this like I did before and rewrite this as the limit as x approaches infinity of 1 minus the cube root of 1 minus 4x, 4 over x, all over 1 over x. That's really sloppy, actually. That's terrible. Okay. What is my next step then? What do I want to do next? Somebody help me out. I'm stuck. What do I do next?
Use substitution for the 1 over x again?
Absolutely, all day long. So I'm going to come over here and say, let u equal 1 over x. As x goes to infinity, u is going to go to 0. So go ahead and finish this question off, and then I want you all to give me an answer. I'm going to put this on pause, and I want you all to work through that. So doing that replacement, I now have the limit as u goes to 0 of 1 minus the cube root of 1 minus 4u all over u. Now we're going to go ahead and do the derivative of this, because we now have L'Hopital's. It says I'm going to get 0 in the numerator and 0 in the denominator, so I can use L'Hopital's. So I'm going to do the derivative. So this is going to be equal to the limit as u goes to 0 of, in the numerator, when I do the derivative of 1, it's going to be 0, so I'm not going to write that. And I'm going to go back to writing this as 1 minus 4u raised to the 1/3, so that when I do my derivative, it'll be a little bit easier in terms of bringing that power down. And so this is going to be minus, because it's a minus to begin with, minus 1/3, 1 minus 4u raised to the negative 2/3, so I subtract a power. Then I have to multiply by what's inside the cube root, which is the derivative of 1 minus 4u. So that's going to be 0 and then minus 4, so it's going to be a negative 4 right here. In the denominator, I end up with the derivative of u, which is 1. Now I can do direct substitution. So I end up with a direct substitution, I have negative 1/3, and then 1 over 1 minus 4 times 0 raised to the 2/3, multiplied by negative 4, keep touching that, I don't want to, multiplied by negative 4, all divided by 1, and so I end up with negative 1/3 multiplied by negative 4, so in other words, I get 4/3. Did I make a mistake with my signs somewhere? So we're getting some negative 4/3. Did I make a mistake with my signs?
Why is there a negative attached to that, or if not, if they're supposed to be, then you have your signs right, I think.
So for the derivative, if I asked to do the derivative, so d du of 1 minus 4u, then the derivative of 1 is 0, but the derivative of negative 4u is negative 4. Does that answer your question? Are we good? Let me see.
Yeah, I think the signs are right.
So the other question was, why is this a negative 1/3? And that's because this is a negative out front to begin with. So when you do the derivative of the cube root, because it's a negative cube root, that's why the 1/3, when it comes down out front, is going to be 1/3, but because there's a negative as a multiplier to begin with, that's why it's a negative 1/3. Otherwise, it would have been, if that would have been a plus here, then that would have been a plus there. But because it is a minus the cube root, that's why it's a negative to begin with. Any other questions? These are really good questions. Thank you for asking these questions, because I'm sure there are other people that are having the same issues. Any other questions you have on this? Okay, cool. So let's take a look. If there's no other question, then one more time. Any other questions you have for me before we move on? Because I want to make sure you know how to do the U substitution, because you can use the U substitution when you see that 1 over x type thing to make it easier to do the derivative. See how much easier this derivative would have been had I tried to do it the other way. This is much easier. Okay, so if we don't have any other questions, then we're going to go into the very last types of the L'Hopital's. So when I have the form of 1 raised to infinity, when I have the form of 0 raised to the 0, or infinity raised to 0, then these types of forms, what I have to do is I have to end up introducing the natural log. And the reason I end up using the natural log is because if I introduce the natural log, I can use this rule. So the rule says that if I have a function as x approaches some number of a function raised to a function, then I can evaluate it as e to the L. So then all I have to do is figure out what L is. Well, what L is this. L will be the limit as x approaches a of g of x multiplied by the natural log of f of x. So once I do that, what I'm hoping for is that g of x and f of x, when I've done that, is either 0 over 0 or infinity, or I can force it to be one of those two. So as I take a look at my first example here, what I have is I end up with 1 to, so this one ends, if I put in 0, I'm going to have 0, 1 to the 0, 1 to the infinity. Sorry, I'm going to have 1 to the infinity. So this is one of those indeterminate forms, and in particular it is this 1 to infinity type right up here. So the way in which I address this one is, the first thing I do is I say let y, or actually, you know what, let's use u because we like u substitution. Let u equal 1 plus 4x raised to the 3 over x. And then what I'm going to do is I'm going to take the natural log of both sides. So the natural log of u is equal to the natural log of 1 plus 4x raised to the 3 over x. And once I've done that, I can use the rules of logs. I have this rule by the logs that says if I have some log, let me do this in a different color. If I have some log based b of m raised to the p, then the p will come down out front as a multiplier, and I have the log base b of m. So this is called a power rule for logs, exponent rule for logs. So I'm going to bring that 3 over x to the front as a multiplier. So the natural log of u is equal to 3 over x, the natural log of 1 plus 4x. I'm going to stop and see, does anyone have any questions so far?
So now it's in the form for L, right?
Yeah, so now what I want to do is I want to see, because right now I'm getting to this L form, this is where I am, and then I want to see whether or not I have 0 to the 0 or infinity over infinity. So if I take only this portion of it, and I do the limit as x approaches, and in this case I was approaching 0, as x approaches 0, so make sure that you pay attention to what your limit was going to, as the limit as x approaches 0 of 3 over x, the natural log of 1 plus 4x. I ask myself, I'm going to just rewrite this as the limit as x approaches 0 of 3, the natural log of 1 plus 4x, all over x, because I'm allowed to do that by the rules of algebra. I ask myself, is this 0 over 0 now, or infinity over infinity now? Do I end up with 0 over 0 or infinity over infinity? And if the answer is yes, then I can go ahead and do L'Hopital's. So, and the answer is yes. I'm going to put, if I put in 0, this ends up being the natural log of 1, which happens to be 0. And if I put in 0 here, I get 0. So I do end up with 0 over 0. So I'm allowed to use L'Hopital's. So since I'm allowed to use L'Hopital's, I'm going to go ahead and do that. I'm going to bring 3 out front because it's just a multiplier. I'm going to do the limit as x approaches 0. And now I'm going to do the derivative of the numerator and then the derivative of the denominator. The derivative of the numerator is going to be 1 over 1 plus 4x, and then multiplied by the derivative of 1 plus 4x, so that's the derivative of 4x is just 4. In the denominator, I get just 1. So what I end up with then is 3, the limit as x approaches 0 of 4 over 1 plus 4x. All over 1, but I'm not going to write it over 1. I can. There's no reason I can't. I just don't want to. So now I ask myself, can I do direct substitution? And the answer is yeah, I can go ahead and do direct substitution. And so what I end up with is 3 multiplied by 4 over 1 plus 0 with the direct substitution. So I end up with 12. So that's what I end up with. I end up with 12. Now, remember, the whole purpose of doing this is to get me my L value. So that is my L value, and if that's my L value, then I can come back over here and say, based on what I just did, that this is going to be equal to E raised to my L value, which happens to be E raised to the 12. And that's my final answer. So I'm going to stop. I'm going to ask you, what kind of questions do you have for me? The reason my answer isn't just 12 is because I'm using these rules up here that says if I have a power or if I have a function raised to a function, then I have to do this intermediate step and said, okay, what I really want to do is find this L value, which is saying L is equal to the limit as x approaches whatever our number is of g of x, the natural log of f of x. And then I can use L'Hopital's. But it's an intermediate step, so that 12 is just an intermediate step. It's not an answer. Because I'm using that intermediate step, the real answer is going to be e raised to that L value I just found, which was 12. Because my original function does not, as I look at this, my original function here, my f of x raised to the g of x, doesn't initially include e. So what I'm using is I'm using a rule that says if I have any number, say, let's do 3 to the x, I can rewrite this as a base e. And the way I rewrite this is I write this as e raised to the natural log of 3 to the x. And the reason I'm allowed to do this is because in my rules of logs, it says if I have b raised to the log base to b of x, then this equals x all day long. So I didn't initially have that in there. I didn't initially have the natural log in there. So what I'm really doing, because I don't really have the natural log, is I'm taking this portion right here and I'm rewriting it using that rule that says if I have b raised to the log base b of x. So what I'm really doing is I'm rewriting this as e raised to the natural log, because it is base e, of 1 plus 4x raised to the 3 over x. So once I realize that I'm using that and changing it to a base e by the rules of logs, that then what I'm finding is when I get down to doing this here, what I'm finding is the L. And that's how come my answer is e to the 12. Does that answer your question?
Yeah, it does.
You just don't like the answer. That's okay too. Okay, do you all want to try B or C, or you want me to do another one before you try this? What do you want to do? You want to just jump in and try this? Or do you want to have me do another one? Okay, so let's go ahead and I'm going to go ahead. Somebody asked me to do C, so I'm going to do C, and then I'm going to have you all do B. I'm just going to erase this over here so I can give myself some room. So let me do a quick erase on this. Oh, not that. That's not an eraser. Okay, so let's go back over here and do C. So what I'm going to do again is just like before, is I'm going to let u equal. So let u equal, and then 1 plus 1 over x raised to the natural log of x. And then I'm going to do the natural log of both sides, so the natural log of u is equal to the natural log of 1 plus 1 over x raised to the natural log of x. And then this is going to be equal to the natural log of x, that exponent's going to come down out front, multiplied by the natural log of 1 plus 1 over x. So I'm going to look at the limit as x approaches infinity of the natural log of x multiplied by the natural log of 1 plus 1 over x. And then I ask myself, can I do L'Hopital's as it stands right now? And as I do L'Hopital's as it stands right now, I can't directly do L'Hopital's because as x goes to infinity, I end up with infinity for the first one, and I end up with 0 for the second one. So when I put in x goes to infinity for a natural log of x, that's going to go to infinity. And then as x goes to infinity, I'm doing the natural log of 1, which is 0. So because of that, I've got to decide which one I want to use in the denominator. So I have to decide which one I want to use in terms of the natural log. So I'm using this 1 over b is equal to b type form. So I'm going to reverse that. And which one I want to use? Well, I'm going to use the natural log of x because it goes to infinity. So if I have 1 over the natural log of x, it will go to 0. So I'm going to rewrite this as the limit as x goes to infinity of the natural log of 1 plus 1 over x over 1 over the natural log of x. And I'm going to stop and ask if you have any questions. What kind of questions you have for me before I move on. We can apply L'Hopital's now is because what I end up with is I put in infinity, this numerator is going to go to 0, and the denominator, because it's 1 over infinity, is going to go to 0 as well. So now I have the 0 over the 0, so I can use L'Hopital's at this point. So what I'm going to do is I'm going to just do the derivative of the numerator and denominator off to the side. So I'm going to go ahead and do this derivative dx of the natural log of 1 plus 1 over x. And I'm just going to do the derivative of the numerator and then the derivative of the denominator separately, and then putting them over each other again. So I'm going to bring them back together in a minute. So this is going to be 1 over 1 plus 1 over x. And then I have to do the derivative of 1 plus 1 over x. I'm going to rewrite this 1 over as x raised to the negative 1. So that when I do the derivative of that, it's going to make it a little bit easier for me, because it makes it easier for me to see the exponent. And so this is going to be multiplied by negative 1 x raised to the negative 2. I'm going to go ahead and just rewrite this algebraically. I'm going to clean this up algebraically. So I'm going to simplify this, and I have negative 1 in the numerator. And the way I got negative 1 is I multiplied this one, negative 1, and this 1. So I get negative 1 in the numerator. And then I have 1 plus 1 over x multiplied by 1 over x squared. And because this and this, those two are both in the denominator, I can multiply this through. And this is x squared over 1. So I'm going to go ahead and multiply that through. And so I get negative 1 in the numerator. And then distributing the x squared onto the 1 and onto the 1 over x, I'm going to get x squared plus x. So that's what I got for the numerator. So I'm just going to come back over here and say, okay, and this is going to be the limit as x goes to 0 of negative 1 over x squared plus x. That's just the numerator part. I'm now going to do the denominator part. And to do the denominator part, I'm going to do the derivative d dx. And I'm going to rewrite this as the natural log of x raised to the negative 1. And now I have to use the chain rule. So before I do the chain rule, is anyone opposed to me erasing this part right here? Because I need this space. I'm waiting, there's a little bit of a lag. Is anyone opposed to me erasing that part? No? Okay. So I'm going to go ahead and erase that part so I've got myself some space. And so this is going to be equal to negative 1, the natural log of x raised to the negative 2. And then I'm going to multiply it by the derivative of the inside, which is going to be 1 over x. So I am going to algebraically simplify this a little bit, and so it's going to be negative 1 over x, the natural log of x. And again, I get a negative 1 because of this negative, and this 1 gives me a negative 1. And that should be the natural log of x, the quantity squared. So what I have now is I have negative 1 over x, the natural log of x, the quantity squared. So is there any questions on that before I move on? How I got to that point? Okay, So I'm going to clean this up algebraically because I don't like it. It's really ugly. And even though I did the derivatives individually, I am allowed to, within limits, to manipulate algebraically as long as it's correct manipulations to make my life easier. So I'm going to do that. So I have a -1 here and I have a -1 here. And so that's going to make it a positive. So this is going to be equal to the limit as x approaches 0. Now, I'm going to use this on the denominator. I'm actually going to go from 1 over b to just b. So this is going to be equal to 1 over x squared plus x multiplied by the reciprocal of the denominator, which is x, the natural log of x, the quantity squared, over 1. Now, rewriting this, I have the limit as x approaches 0. In the denominator, I have x squared plus x, so I'm going to factor out an x. And when I factor out an x, this x and this x will cancel. So what I have is the limit as x, the natural log of x squared over x plus 1. And I'm going to wait, see if everyone has any questions for me. Okay, so now I'm going to do L'Hopital's again. In other words, I'm going to do the derivatives again. So when I do the derivatives again, I'm going to get 2. I'm going to do the limit as x approaches 0 of 2, the natural log of x to power of 1, multiplied by 1 over x, divided by 1. And as you can see, I can't quite put in 0 yet. The limit as x approaches 0, I'm going to bring the 2 out front, natural log of x over 1 over x, 1 over x. So I'm going to do L'Hopital's again. So I have 2, the natural log limit, the limit as x approaches 0. The derivative of the numerator is going to give me 1 over x. The derivative of the denominator is going to give me -1 over x squared. So this is 2, the limit as x approaches 0. Cleaning up this algebraically is just going to give me -x. The reason that's going to just give me -x is because this is going to be 1 over x multiplied by -x squared over 1. So I just get -x. And now I finally get to do direct substitution, and my final answer is 0. That's a whole lot of work to get 0 as the answer. But it's really not the answer. we have to go back and say this is equal to e to that L value, because all of this we were doing was chasing that L value. And so my final answer, going way back here, holy crap, did we have a great time doing this, is my final answer, this is going to be equal to e raised to the L, which is e to the 0, which is 1. So if you want to impress your friends and family and they ask you how many hamburgers you want or how many deviled eggs you want this weekend for deviled eggs for Easter, because that's what we do, you're going to tell them you would like the limit as x goes to infinity of 1 plus 1 over x raised to the natural log of x deviled eggs this weekend. That's what you're going to say, and they're going to be so impressed. They're going to say, I know exactly what you're saying, son or daughter, because I get this. Or they're going to look at you like, WTF. So let me go back. I know we're over time, but that's okay, and I appreciate you all hanging out in here. There's a lot that went on this problem. Does anyone have any questions along the way? What kind of questions, I should say, do you have for me?